All right, bearings. I think this is another thing that causes some issues for some students from time to time as well. So with bearings, there's three key words that I want to point out before we start, and they are from, to, and due. So the word from, whenever you read an expression, a sentence, a question, and it has the word from, that usually is the indication that whatever is from, that's your starting location, and things get measured at that point there. To, that is your destination. That is where you are going. So that is where you are going to end up once you've moved along a distance through a bearing. And finally, that word due means exactly. So if something is due south, it is exactly south. And we saw that previously with that question with the kookaburra, where we said that it was 15 meters directly beneath the kookaburra's feet. We could have described that as due south of the kookaburra's feet, exactly south. All right. So hopefully that helps keep those things in mind as we go through what we're talking about. Cool. The first one I want to come across and talk about are compass bearings. So there are two main types of bearings that you'll get asked to use. You'll get asked to use compass bearings, and you get asked to use true bearings. A compass bearing, the way that we classify compass bearings is that it, from your starting point, not much, mate. From our starting point, you look north or south first. So wherever you're, say, starting from, your first thing you need to figure out is, am I looking north or am I looking south? Once you know that part, you then need to figure out how many degrees are you turning, and are you turning east or are you turning in a west direction? All right. So it's always look north or south first, then rotate degrees either east or west. And let's have a look at that first example there. The first example there asks you to draw a diagram to represent the fact that town A is on a bearing of north 50 degrees west from town B. So there's that word from, and it's from town B. So town B is our starting location. If we have a look at our bearing, we'll ask, the first thing we will ask to do is to look north from our starting location. So town A is north of town B. So what I'm going to do, down my page a little bit, I'm going to write town B. So there's town B. And I'm told to look north from town B. So I'm just going to draw a north arrow in. So there's north. All right. Then I'm told to turn 50 degrees. All right, so I know I'm moving 50 degrees away from north, and that's in a westerly direction. So 50 degrees. So we want to go this way, 50 degrees. And we're over here somewhere, and that would be where town A would be located. So in example 2 here, you have a man walks 10 kilometers due south from point A to point B. All right, there's a lot of words, worded question here, so we're going to take our time to go through it. After he walks south, he then turns east and walks for 8 kilometers to point C. Right, so those first two sentences have described some movement patterns for us. The third sentence states, to the nearest degree, what is the compass bearing of point A from point C? So the third sentence tells us to do something. So let's go ahead and draw a diagram. So a man walks 10 kilometers south from point A to point B. So there's the from, so point A is our start, and there's the to, point B is our destination. So if we draw that, 10 k's due south. So if that's point A, we go exactly south. We go 10 kilometers south, and there's point B. He then turns east. So east in this diagram, it would be, well, east is to the right, and walks to point C. So there's another destination. Now we're going to go 8 kilometers to point C, and that's east. So we're going to turn east. So there's a direction east, and that's 8 kilometers. And there's point C. Now, nowhere in this question has it mentioned anything about 90 degrees. But what we do have is we have a line that went south, and then from that south, they went east. So we know, because it mentions due south and then east, that's at right angles to each other. And what we have here is we've got a triangle. We have a right angle. We know two sides. So we've got a diagram. Now let's go through and look at that third sentence. What is the compass bearing of point A from point C? So what we have here is there's another from point C. So what we have here, if we think about this, and I'm going to do this in a different color now. Let's go purple. We've been asked to start at point C and describe how to get back to A. So we can see from our diagram that A, it's north of C. So we know our first part is going to be look north. So we know the first part of our answer is going to have north written in it. Now we need to figure out, well, what direction are we turning? Are we turning east or west? And we know it, because A is to the left of point C, we know we're going to go west. So we know our compass bearing so far, it's going to be north something, west. We've figured out those two just by looking at our diagram. What we need to know now is how many degrees do we turn west? What we do know, I'm going to change this to green, that if I have a line that runs south-north and I have a line that runs north, I know those two lines, they're going to be parallel to each other. North-south lines, they're always parallel to each other. If I have a 90-degree angle over here and I've got two parallel lines, I know from co-interior angles that, and I'm going to do this now in orange, this part must in total also be a 90-degree angle. Now, looking back at my question, I don't really have too much information outside this triangle to help find this question mark. But what we do have is we have a triangle, and because we have a right angle triangle, I know how to find the angle that's inside that triangle. We know how to find that angle inside there. We know how to find angle BCA. Because we know how to find that angle in there, we can then use complementary angles to figure out our last part of our bearing. So our first thing we need to figure out is what is the value of angle BAC. And so the angle BAC, that is going to be, well, I have an opposite and adjacent side, so that is going to be tan of the angle is equal to opposite over adjacent, 10 over 8. So theta is going to equal inverse tan of 10 on 8, which is going to equal 51 degrees, 20 minutes, 24.69 seconds. So so what we have there is 51 degrees when I round that to the nearest degree. Our bearing is just going to equal to 90 minus 51. So 90 minus 51. So it's going to be north 49 degrees, not 49. North 39 degrees west. Was that okay? Yes, it is. Sorry, my bad. Thank you. B, C, A. Thank you, Grace. So example 3 here, an airplane leaves Sydney Airport and flies on a bearing of south 30 degrees west for 600 Ks. It then turns due east and continues flying until it is exactly south of the airport. How far south of Sydney is this? So same thing again, we're going to draw a diagram and we're going to take it step by step. All right, so we know that a plane leaves Sydney Airport, so that's our starting point, and it flies on a bearing of south 30 degrees west. So because I know the plane is moving south of the airport, I'm going to draw the airport towards the top of my diagram. So there's the airport. All right. And what I know is it's south, and then I turn 30 degrees to the west. And that's for 600 kilometers. So that all that part of my diagram so far is just that first sentence. The next part of second sentence says it then turns due east. So that means exactly east. So if that was where, off that point with the airport, if north is going to be directly up, the plane then turns east and flies east. And it flies east. But it flies east until it is exactly south of the airport. And you can see I've stopped it there. And I'll change color so you can see now it is exactly south of the airport. Now it's important that it said exactly south of the airport, because if something's due east and exactly south, we have now another right angled triangle there. And then the question says, how far south of Sydney is the plane? So what it's asking for is, what is that length there south? And hopefully right now you can see that's now just a simple trigonometry, a right angle trig. It's the adjacent side and the hypotenuse. So we're going to have cos of 30 degrees is going to be x over 600. So x will be 600 times cos of 30 degrees, 519.615 ... All right. One thing I just want to throw out there, what I just did there, nowhere in the question did I mention how many decimals I wanted it rounded to. There's two ways you can then approach that. You can see here that 600, it was the only other distance. It was given to you in whole numbers. So you could either leave it as a whole number, or you could just round it to one decimal place and tell the person who is marking your work, is reading your work, that, hey, look, I've rounded my answer to one decimal place. So true bearings, what they're slightly different to compass. True bearings are always measured from north in a clockwise direction. So you always, no matter what, wherever you're starting from, you look north and you turn clockwise. They're always given as a 3-figure reference, followed by a capital T. And what I just want to zoom in on at the moment is sometimes a compass rose, thinking about a compass rose helps us. And that we know that, well, let's undo that. Let's make my pen a bit smaller. We know that east is 90 degrees clockwise from north. We know that south is 180 degrees clockwise from north. And we know west is 270 degrees clockwise from north. Northeast, southeast, southwest, northwest, they're all exactly halfway. So I know northeast is 45 degrees. 45 plus 90, that gives me 135 degrees. So southeast is on a bearing of 135. Southwest, 180 plus 45 gives me 225. And northwest is then on a bearing of 315 degrees. Right? Not super important that you commit them to memory and memorize all those numbers, but it is amazing how often 135, 225, and 315 degrees appear in questions. And we know, and the importance about that is I know that northwest and southwest, if I only just look at northwest and southwest, the difference between 315 degrees and 225 degrees is 90 degrees. So I know that a southwest line and a northwest line, they're at right angles to each other. So sometimes it's handy to remember that if something's northeast and southeast or southeast and southwest, if those are the two bearings, that those also meet each other at 90 degrees. And it's amazing how often those angles tend to creep into questions. So it could be just something handy, and obviously north is going to be 0 degrees. So something handy to think about. All right, so coming back to our example, the first example there, true bearings always made from north, clockwise. I haven't actually given you an example there. What I want you to do, what we're going to do here is we're going to draw a diagram to represent a bearing of 8 degrees true. So you can see how it's 3 figures, 0, 0, 8 degrees, followed by my T, 8 degrees true. So if I pick a starting point, and then I look north, always look north, and then I turn clockwise 8 degrees, and that's my bearing of 8 degrees. It's look north, turn 8 clockwise, and go. Does that, hopefully that's okay. If I look at question B, a diagram of a bearing of 250 degrees T, straight away my mind starts to think, well, 250 degrees, well, that's close to 270 degrees. Hopefully you all agree with that. And because 250 is closer to 270, that's kind of, if I was to think about compass rose, kind of lives in my southwest area. So that kind of just helps me mentally picture what my diagram might look like. So if I pick a point, draw my north arrow, and then I rotate clockwise 250 degrees. And that would be a bearing of 250. So we've got a question here. A boat is on a bearing of 120 degrees from port. So what we have there is something nice and beautiful. We have that word from, so we know our starting location. We know we're starting at port. We know it's on a bearing of 120 degrees true. Well, 120 degrees, that lies between east and south. So that's southeast-ish. So we straight away starting to think about, I've got a rough picture in my head, what is this diagram going to look like? So I'm going to draw a diagram that's going to be port. I'm going to draw a north arrow, and from north, I'm going to rotate 120 degrees. Now my diagram needs to be below east, and out here somewhere, let's call it there, that's fair enough. There is the boat. All right, so everyone, hopefully you guys are okay with that diagram. Now we're going to go look at the next part of the question. The question says, what is the true bearing of the port from the boat? So here is our from the boat part. So what we need to do what we're looking for is from the boat, oh, that was dodgy. Let's undo that. We're going to look north. And once we look north, we're going to rotate clockwise until we look back at port. So that's what we are asked to find. Hopefully you guys are starting to see that I don't know really anything about the purple line I've just drawn, but what I do know is that that's north and that's north, and I know that two north lines are always parallel to each other. And I know something about one of the interior angles inside. Yes, Ruben, beautiful, you got there before I did. We've got co-interior angles here. I know something about one of my angles. So if I call this theta, theta is going to equal 180 degrees minus 120, which is 60 degrees. And I'm just going to do some little setup here. I'm going to call that north 1. I'm going to call that north 2. And I have co-interior angles, because north 1 is parallel to north 2. All right, so that's 60 degrees, but that hasn't answered our question yet. All we know that is 60 degrees in here. But of course, now we know that's 60 degrees in there. Let's do it down here. Therefore, the bearing is going to equal 360 minus 60, which equals 300 degrees true. And that is the angle of a revolution, or angles at a point. So I've used my knowledge about angles at a point, and there we've answered our question. All right. With bearings, a lot of our angles around parallel lines come into play, and we've got to be comfortable being able to use them and manipulate them and play with them. And we'll wrap up on this last example here. So a helicopter flies for 1.5 hours at 130 kilometers per hour on a bearing of 040 degrees true. After it does that, it then turns on a bearing of 130 degrees true and continues to fly for 2 hours. All right, so that's information there that just tells us how to draw our diagram. And the first question we'll ask is, how far is the helicopter from its starting position? So what we need to do, let's draw a diagram. So let's start off with that first sentence. It flies for 1.5 hours at 130 kilometers an hour on a bearing of 040 degrees T. So that means 40 degrees. That's that northeast somewhere. So I'm just going to chuck a point in. I'm going to label it S because that's my starting position. There's my north line. That one is 40 degrees. And then the helicopter flies to there somewhere. Let's not put it there. Let's make my life easy. Flies to there. What distance did that helicopter cover in that stage? Yeah, Ruben, 195 kilometers. Cool. Love a few people jumping on there, 195, yeah. And we got that from 1.5 times 130. Once we got to that position there, I don't know whatever you want to call it. I'm going to call it point B because my name's Brad. So once we got to point B, it then turned on a bearing of 130 degrees true. So draw my north arrow. 130 degrees, that's heading back towards that southeast-ish. So I'm just going to go like this. And we know that that's 130 degrees. That bearing there is 130 degrees. We know that. And that's currently where the helicopter is. So I'm going to call it H. So there's our diagram that describes the first two. It flew for 2 hours. So that's going to be 2 times 130. So that's 260 kilometers worth of distance. Cool. So we've got our diagram drawn. Part A says, how far away is the helicopter from its starting position? So part A, it wants to know, what is that distance there? Cool. Having a look at that distance there, well, we've got a triangle. We need to know some angles in the triangle. We need to know, is there a right angle in there? 325. Sana, how'd you get 325? Pythag. Beautiful. Yes, but Pythagoras only works in right angle triangles. Do you know for sure this triangle is right angle just at this diagram at the moment? No, we don't. I'm going to give you the heads up. it is a right angle triangle, and we're going to go through and prove that now. Now, having a look at it, X, by the feel of our diagram, it's going to be the longer side. So we're going to assume point B is right angle. And when I look at it, I don't know enough information. I don't know enough information to find this angle. I don't have enough information to find that angle there. But what I do have, I know enough information to find this angle inside. And the first thing I need to do to find the angle inside is I need to know what the angle up the top is. And theta is just going to equal 180 minus 40, which is 140 degrees, and they are co-interior angles, because that would be north 2 and north 1, because north 1 is parallel to north 2. All right, so we know that that's 140 degrees in there. Angle B is going to equal 360 minus 130 plus 140. And funny enough, that's going to be 90 because they are angles at a point. So Ethan, yes, B is 90 degrees. That makes life nice and easy. Yes, so the question when it says how far is the helicopter away from its starting position, we want to know from where the helicopter is currently at H directly straight back to the starting position. All right. So when it comes to these questions here, before we can go through and apply Pythagoras, we need to prove that it's a right angle triangle. And that math that we just did there, using our bearings, using angles at a point and parallel lines, proves that it's a right angle. So the distance is just going to equal 195 squared plus 260 squared. Oh, not degrees. And I want the square root of that. Because S can't be 90 degrees, Rhea, because S can't be 90 degrees because it's 40 degrees away. We don't know, we only know that that's part there, Rhea, is 40 degrees. We don't know if that purple line is exactly east of the starting position. We're not sure. We'd have to do a bit more maths to figure out if it's exactly east. So Ethan, we can't say S is 50 degrees either. The only thing we can say with certainty is we know B because we can quite easily find the 3 points around B. And I think, what did we say it was? 365 kilometers, I think it was. Was it? 325, sorry. So that's the only thing we can say for certain. Is everyone comfortable with playing around with those bearings up the top to prove it's a right angle to then carry on? Part B to this question says, on what true bearing must the helicopter fly to return to its starting position? What we've been asked to do here, and now that I think about it, this question is going to be kind of straightforward-ish. Yep. We've been asked to figure out on what true bearing must the helicopter fly to return to its starting position. So if I draw this in green, what that means is starting at the helicopter, look north and rotate clockwise until you see the line that takes you back to the starting position. So that's what we've been asked to find. I'm going to call that north 3. So before we can do any of that, let's add some more information. Well, if we think about that, what would be handy to know to figure out this? And when I'm looking at it, if I know what this angle size in here is, and this angle size in here is, I can use angles at a point, and I can figure out my true bearing. So they're the two things we need to answer here. So let's call that X degrees, and let's call that Y degrees. So let's start off with X degrees, because X degrees is feeling pretty easy to figure out straight away. X degrees is just going to be 180 degrees minus 130 degrees. And they were co-interior angles, because what is it? North 2 is parallel to north 3, right? So hopefully you guys from the previous examples saw that straight away co-interior angles are going to apply there. So we know what 50 degrees is. Why? Well, we've got absolute choice of option with y. Y is inside a triangle. So what I'm going to do with y, let's pick this purple color. I'm going to use the adjacent side and the opposite side. So tan of y is equal to, what have we got? Opposite over adjacent. So 195 on 260. So y is going to equal inverse. All right, so we know that y is 36 degrees, 52 minutes. The bearing is going to equal 360 degrees minus the sum of x and y. So minus 50 degrees plus 36 degrees, 52. So that's going to be 273 degrees, 7 minutes, 48.37 seconds. So I'm going to round that to 273 degrees true. So if the helicopter flies on 273 degrees true, it gets back to its original starting location. And that's bearings, that's some true bearings. And again, true bearings, the fun part about true bearings is using your knowledge about angles around parallel lines to help, and right angle triangles to break down and problem solve what you know and what you don't to find answers.